Okay, our last few examples for lesson 4.1. We're going to talk about zeros. Reminder that if f of x equals 0, then the values where that's true are called the zeros of a function, or they could be the solutions of the equation. So a polynomial function has a linear factor x minus a if and only if, when I put a in for x, I get 0. In other words, if my remainder is 0, it's a factor, and if it's not, then it is not a factor. So if a is a solution of f of x equals 0, then x minus a is a factor. If x minus a is a factor, then a is a solution. So they want us to show that x minus 3 is a factor of this function by using the factor theorem, and then find q of x, which q of x is going to be the quotient that we get when we divide by x minus 3. So to do this, we're basically just going to do synthetic division. Since our value of a here is going to be 3, we'll use 3 and do synthetic division. Remember, we're going to use the coefficients. Coefficient of x cubed is 1. Coefficient of x squared, negative 4. Of x is 2, and then my constant. So the reason I'm going to use synthetic division is because they want us to find the quotient. So I need to know everything I'm going to get here. I'm going to end up using that whole thing. 1, to determine if it's a factor, and then 2, if it is a factor, then I already know what the quotient is. So we bring down our 1. 3 times 1 is 3. Negative 4 plus 3 is negative 1. 3 times negative 1 is negative 3. 2 minus 3, negative 1. 3 times negative 1 is negative 3. Add these together, I get 0. So since the remainder is 0, it is a factor, which means then that my quotient q of x is going to be, this is my constant, okay, y-intercept. Here's my x squared. So we have x squared minus x minus 1. Which this means then that x minus 3 times x squared minus x minus 1, when I multiply that, it equals this right here. Okay? So just a matter, we do division, we get a quotient, I multiply the quotient by the divisor, and I get my dividend. So it's a factor, so then here is the quotient that I get from doing it. So I can say that these two things multiplied together is equal to this. So a reminder, if I take a function and I set equal to 0, I find out where it crosses the x-axis. Those are called the x-intercepts of the graph. Those are also called the zeros of the function. And if I set it equal to 0, then there's solutions of the equation. And then once I find those numbers, I can actually use those as linear factors for it. So what I'm going to do is find the zeros. If it's a very difficult equation like this one is, I'm going to find the zeros by graphing. So I'll take out my calculator and put it into my y equals 15x cubed minus x squared minus 114x plus 72. Now all I care about is the zeros. So where does it cross the x-axis? I don't care about max and mins, any of that. All I care about is the zeros. So this is a cubic function, so it's going to have 3 zeros. So the first 0 that I have looks like that might be only one of them is a whole number or an integer. Let's look at our table just to verify. Right, so we have one is negative 3, but that's it. Okay? The other 2 zeros I see in my graph are not integers. So I'm going to have to work a little bit harder to find them. So I have 1 0 at negative 3. And so what I'm going to do with that 0 at negative 3 is I'm going to do synthetic division to help me to find the other ones. So I bring down to 15. Negative 3 times 15 is negative 45. So this is negative 46. Negative 3 times negative 46 is, let's see, that's 18 and 138, and that's positive. So this is going to be 24. And 24 times 3 is 72. So negative 72, we get 0 here. All right. Which it better be because we found that as a 0. Okay. So now we have 15x squared minus 46x plus 24. Now that's going to be kind of tough. We can probably factor that. Probably not going to be easy to factor, but we can do it to help us find the zeros. Now you could use the slide and divide method if you want. That would all get pretty tough doing it, but you can actually do that. So let's do that slide divide for a second. So first of all, we need to multiply 15 times 24. So we get 360. So we need to know the factors of 360 that are going to add up to 46. Okay. So 360, so we'll go into our y equals and do 360 divided by x. And we want to find two numbers that when they add up to 46. So let's see. There's 66, 53, 49, and 10 and 36 is 46. So this would be x minus 10 and x minus 36. And since we are doing slide divide, we need to divide them both by 15. So we simplify them, x minus 2/3 and x minus, let's see, 36 over 15, 3 will go in both of those, and that would be 12 over 5. Then we're going to slide to 3, slide to 5. So my zeros are going to be negative 3, positive 2/3, and positive 12/5. There's my 3 zeros. Okay, so that's part of my answer there. When I write in factored form then, I'm going to have x plus 3 for this 0. And then for down here, I'm going to have 3x minus 2 and 5x minus 12. So here's my linear factors. So I wrote it with linear factors, wrote it with the zeros. Okay. All by finding the zeros. Remember that once you find the zeros, you can write them as opposites, and they are the factors. Let's finish this up. We got a couple more, 2 more examples, almost done. Okay, find 3 polynomials of different degrees that have, and we're going to use -1, 2, and -4. So all I do is write it as f of x equals, here's the zeros, here's a polynomial. This polynomial has degree 3 because I have 3 linear factors. So it says to find 3 different ones. Well, to find the other 2, you can do just about anything you want. It says different degrees, so what I'll do is I'll just raise one of those to a different power. Okay. This one now has a degree of 4. Because I have 2 here. Remember we talked about multiplicity before in algebra C? So this one has degree 2, so it's multiplicity of 2, degree 1, degree 1. So I add them together and I get 4. So then to get the third one, then you could just make this a 3. You could change one of those, whatever you want to do, but it would have to be degree 5 or 6 or something. And then the last thing is, number of zeros that a polynomial might have. A polynomial of degree n has at most n distinct real zeros. In other words, whatever the degree is, it could have that many zeros. It won't necessarily have that many zeros, but it could have. Here I have f of x equals x to the fourth plus 3x squared minus 2x plus 1. The degree of this polynomial is 4, so it could have 4 zeros. And that would be the end of that lesson.